So as mentioned that this is Lisa. I'm the DevOps manager working in HP. I'm located in Shanghai, China.
And this is John. I'm a collaborator with Lisa. I'm a DevOps architect. I'm very happy to have such chance to talk with you. Thank you.
Yeah. So today we were talking about how Istio actually bring the excellent observability to the HP Horizon platform. Okay. Here is today's agenda. We're talking about basically our business platform and what kind of features we have enabled you leverage from the Istio, and also what kind of customizations we have did along with the Istio features. And in the end, we will have the Q&A session. So we want to talk about with our HP Horizon platform designed with the Istio. As you know that HP as a big company, we have lots of projects and deploy on the cloud. Some of project has a common features like the single sign-on, the user management and the payment, etc. And all they also have some specific project features. So John and I are working as a software organization. So we decided to provide a common platform called Horizon, which will major provide two parts. The first one is we are serving the common features as a service. So each solutions, they didn't have to developing the service by their own, but they can leverage our common service in this area. And second one, the Horizon platform, we are also aiming to provide a manager infra for the service for the solution. So solution don't have to care about or operate their infrastructure, but they can loading their service in our manager infrastructure. So in this way, we are hoping that we can maximize the values for the customer and also able to helping our solution be able to delivering the solutions to the marketing with a low cost and with a higher quality. So here is how the platform looks like. So you can see in the right corner, we have a Kubernetes cluster called core cluster. And inside of the core cluster, we have hosting all the core service like the all service, IAM service, payment service, notification service, and etc. And all the core service are supposed to access from the ingress gateway. And then in the left corner, we also have solution clusters. And the solution in our platform, we treat them as an individual tenant. And each tenant will have their own namespace. Their namespace will be isolated using the policy. And their service will also expose from the ingress gateway. So if the solution service they want to consuming our core service, there was through the mutual TMS, and we set up as a solution cluster and the core cluster through the Istio multi-cluster using the rapid control panel plan. And if we have some solution cluster which is hosting by themselves and not running on our manager infra, they can still have the way to consuming our core service from this channel directly. So consider if currently we are building a platform and we are providers this kind of service to our solutions, there must be some requirements we want to fulfill. For example, as we are providing the core service for larger audience and solutions, how we can make sure that our service is performed very well, and how we can get alert if we really have some issues in our core service in time. And the second one, for example, if we onboarding more and more solutions there, then how easily we can tell that when issue coming, is easy to tell this is an issue in the solution or is it an issue in our core service. So we are hoping that we didn't highly rely on the application team to providing hundreds of logs to supporting the troubleshooting, but we are hoping that as an infra, we are able to provide this kind of functionality for people to troubleshooting and monitoring. So I think kudos to the Istio that provide a very excellent observability in order to support this. So how Istio provides us a way is, as we all know that in the Istio side, they are adding a proxy sidecar along with every application deployed. So in this way, Istio will let all the program applications aware for the traffic management and also the encryptable observability. So Istio generates a detailed telemetry for all service communication within a mesh. And this telemetry actually will provide a good way for the service behaviors. So in this way, they can empower us to troubleshooting and maintain and optimize our application. And the most important things, they will not adding any burden to our service developer. So Istio provider the following ways for the telemeters. The first one is access log. So as all the traffic flow into the mesh, Istio is able to generate all the full records of the API request, including the source and destination method. And in this way, it will able to tell you that like the how, when, what of the logins. And the second way for the telemetry is for the metrics. Metrics actually is able to provide a way for monitoring and also helping you to understand the service behaviors in aggregate. And is still able to generate the metrics in a signal like the error, traffic, and latency, etc. And also is still able to provide a default monitoring dashboard out of box. And third thing is for the distributed trace. So Istio is able to generate all the distributed trace spans for each service, and in this way, it will allow you have the insight of all the call flows and also the service dependencies in the mesh. So we will go through each of the items in when we go through all our solutions. So first, take a look for the access log from the envoy. So as I mentioned, as we are working for a platform, it's key for us to know that to show some data like our core service utilization, the performance of our service. For example, if I want to know my core service API access count and my core service API error rate and my core service API response time, how should I do? Because I don't want to ask my core service development team to implement any code for this. I want my infra can tell this data directly to me. So what's the solution we come out? Let's take a look. So this is our solution. So here you can see this is our cluster. You can consider, and inside of the cluster, we are leveraging the FreeND to collecting all the logs. So currently we are our solution are collecting logs from the Istio proxy and also the Istio ingress gateway. So from here, after we collecting, we also passing this kind of logs in for the field which we consider is important. And then we store all the data in the Elasticsearch, and then we can able to view the data and generate the dashboard in the Kibana. So let's take a look deeper how we implemented this. So by default, you were not able to get in the envoy access log from Istio. So in order to enable it during the installation, you have to using the Istio kernel to enable this envoy access log. And once you enable it, you will able to view the logs in this way. Like this is the logs in the Istio ingress gateway, and this is logs in one of the container of the Istio proxy. So these logs looks very similar and contain lots of informations. So let's take a little deeper. What kind of informations will be contained in this log? We highlight some of the key informations we consider will be very useful for us in this access log. The first one is the start time for the API call. The second is the method of your API and what's the really API path, and what's the response code for this API, whether it's success or it's not, and what's the duration for the API, and the REST request ID, which Zheng will also mention later. It's very important information, and what's the host. So after we understanding as a format for the logs, then we can do something which based on our request. So in the friend we are doing the passing of our logs based on the keyword which we think is important in the friend config map. So here is one example we are using in our project. We are passing all the important things like the response code, method, as I mentioned, the proxy, and we store each of the values in our new field which we stored. And after we pass this kind of format, and we are able to store in the Elasticsearch, and then we are able to view this kind of logs in this format, in a more readable format in the Kibana. So in the left panel, this is all the new key we generated based on the logs, and this is all the values we get from the logs. Like as I've said, is a duration, method, the path, and response code, etc. And as long we are able to store this kind of data in this more readable way, and we are able to group this kind of data and generate a report for my needs. So for example, if I want to understanding for the API access count, then I can able to easily, based on the keys we generate, and generate this kind of reports. And also, if I want to understand my API error, what's the top one, then I'm able to generate this kind of report as well. So all of them is based on each API. And also I'm able to, based on my duration, I'm able to see the latency in my API. So I can provide this kind of data and ask a developer to do some troubleshooting based on that. So until now, we are able to have a clear view of my platform of the API performance. And I think this is not enough, because as we are operating the platform, we still want to predicate the alert. And so we can know that is there any issues may happen in the system, and we can get alert in time. So we also put some effort to working for the API monitoring and alert stuff in the platform. And we do meet some challenges as we going on. And some major challenges we have, I think previously is we have some issues which is not reported in time, or maybe some issues is still in the warning level, and we didn't pay attention. And then later on, it's really become as a one incident in the production. So one example I can show you is we have one service, and this service has several API will be exposed to a solution to consume. And one of the API actually is very stable, and but the access rate is also very high and is very stable. So you can consider if you are monitoring on this way, it will always very smooth. But there's also another API inside of this service, which access rate is very low, but it's very critical. If this API failed, it will trigger a critical incident for the solution. So in this way, because our alert is based on the service error rate, then this kind of alert will not get attention in time. So we want to find a solution in order to resolve this kind of situation. So we are also considering what we can do to overcome this kind of challenge. So we are considering that our monitor should be more accurate on the API level, and also can be more predictable. And so we are considering some requirements or rules which we can put into our monitor. For example, if my API error count, not based on the error rate, but based on the error count is very high, or even maybe the count is not high, but the error is already in the trend of increasing, or maybe my API latency is high, or also maybe is in the trend of increasing. So I see some person raise hand. Is there any question so far?
Oh, yeah. I just wanted to be sure if I understood it all right. Okay, nice to meet you. I am Evaldo. But you monitor the error rate of the service, and then based on that, you raise the alert, or is that right?
Yeah. So previously we are based on this. We are we are monitoring the service error rate, and we are alert based on the service error rate. Though, but in this way, we meet some challenge because this kind of alert will not be accurate. So we want to change to the API level instead of the service level. Yeah.
Yeah, that's what I understood. I just want to know if I got it right. Okay.
Yeah.
Thank you.
Yeah. You're welcome. Yeah, and so this is something we come out of requirements. We want to based on the API level, and we can do the monitor. So we look into what the original Istio did for the mattress part. So actually, as I mentioned in the beginning, Istio actually were able to generate lots of mattress by default. And so you can query this kind of mattress from the original outbox of the parameters inside of Istio. And what's more, you can also view this kind of mattress from the graph now. But in this way, you can see this is the service, and I'm able to see my latency and also the success rate. But this success rate is still based on the service level. There also you can see the tracings in the Kiali to see the service dependencies, and also in here you are able to see also success rate for the API call. But this is also based on the service level. So all of them provided from the Istio by default is awesome. But still, as I mentioned, we want to do this kind of things in the service level, in the API level instead of service level. So we have to come out as the solutions by ourselves. So I will hand off to John, and he will give a detailed introduction regarding our solutions.
Okay. Thanks, Lisa. So this is John. So as Lisa said, Lisa already introduced how we get the logs, envoy logs, and how we pass the logs in FluentD, and how we forward to the Elasticsearch. Lisa also introduced current Istio metrics cannot fulfill our requirements because it's on the service level, not API level. Okay, so this is our final solution. So we forward the logs, pass the logs, and save the logs in the Elasticsearch. With that, we already has all the API level data, API information, like the response code, response count, and response latency. Based on this, we do the simple alert with the less alert, or in most cases, we do more advanced alert because we have more complex rule. So we first, for each minute, we're using a cron job to do the data aggregation and save the aggregation data into the database. And we use another cron job to query the database, find out the abnormal data, and send alert with PagerDuty. So as I said, there are two ways. So I would try to explain a bit more. For the simple alert, for the elastic alert, the rule will like match where there is at least X events in Y time. So you can say for a specific API, if its response code is 500 and it raised 3 times in last minute, okay, you should raise such alert. But in most cases, we want to list all the API, and we don't want to list the API one by one in the config file. And we also want to alert only it continues in 2 minutes, like so we need using this our more complex advanced alert solution. So one thing in the mission, although the rule is complex, but our configuration is very simple. We support the YAML file for each rule. Okay, this is aggregation table in database. So we group by each minute, group by service name, API path, API method, and response code. And we calculate the average response time, P90 response time, and the total count in this minute for this group by. Okay, after we get this table, aggregation table, it is very easy to implement our requirements. For the previous requirement is list all API whose response code is 500, more than 3 times, and continue 2 minutes. So we say, okay, we get this data from aggregate table here, and response code is 500, and the more than 3 times in last 2 minutes, and continue 2 minutes. That means both of the minutes has such a case. So you can find with this, it's easily to implement our requirements and resolve our challenges. So based on the API level alert. Okay, so based on the same solution, we think we need enhance our alert by implementing below requirements. So all of them is implemented and works well, like as 500 error rate is more than 5% in the last 5 minutes, like the P90 latency is greater than 500 milliseconds for the last 5 minutes, or sometimes the average response time is not high, but it continue to increase, right? So we will also alert if it increase more 20% in last hour, or we also store the P90 average time in the last week. So we compare current average response time. If it is 2 times of previous last week's P90 average response time, yeah, we will also alert. So in such case, maybe this API is very, very quicker. It is quicker, like less than 100 milliseconds. It is not based on the data. It will not alert better, but it gets slower and slower, maybe, and it is abnormal because compared with previous data, it is abnormal. So we will alert. So we implement all of them. So this is our benefits. After that, we can identify the issues and alert quickly. And it do reduce our cloud platform downtime, and guarantee our SLA and improve our user experience. And definitely it reduced our DevOps workload and it improved our work efficiency. Okay, so let's go to another topic for the Istio observability, the tracing integration. I think most of you are familiar with the tracing. I would like to introduce a bit with 2 popular choices for the tracing. One is Silicon and another is Jaeger. Silicon is developed by Twitter, and it forwards HTTP header XB3, right? And Jaeger is developed by Uber, and now it is a CNCF project, and it forwards the HTTP header is Uber trace ID. They are different. So this is our challenges before we get our solution. So we are using Jaeger, but the spans between the application and the Istio process cannot be connected because their forward format is different. Their trace format is different. And also, it's not easy to match the client request with Jaeger trace because thousands of requests go inside the Jaeger, and for specific request, it's not easy to search it out. Same for the Jaeger chase, you cannot match the logs. I mean, the logs in the friendly, the logs in the Kibana, you cannot match it together. And same, even for the logs, we cannot match the Istio process logs and the application logs. With that, when a client send an API and get 500, it's really a nightmare for debugger. We cannot easily to identify which service fault in a complex service mesh. This is a diagram to introduce our challenge. So client side send a request to service full, and service full will send another request to the service bar. So for each time, it will go through the envoy process, and both of the application and envoy process are send the trace data to the Jaeger. We hope they can connect together better. The envoy process said, I forward the silicon trace format only, and I also forward the X request ID. This is envoy trace ID. But our application said, I forward the Jaeger format because we are using Jaeger. Okay, so Jaeger maybe said, I like Jaeger format, but I'm compatible with silicon trace format. So what can application do? What's the best option? Can I forward all of them? Yes, our solution is yes. Application forward all below heads, includes the Jaeger format like Web trace ID, includes silicon format like BXB3, trace ID, span ID, parent span ID, and includes the Jaeger envoy tracing X request ID. Besides that, we do an additional step. All the application, when they print their log, they were using the X request ID as a prefix. You know, for the Istio ingress gateway or the Istio process, they already print out the X request ID in the envoy access log. That's we can connect them together. Is this solution complex? So need a developer cost a lot of time? No, it is very easy. As long as you add this green part code, you can implement this. So previously for integrate with Jaeger, so you need only add this part when you new tracer. And now, in order to compatible with silicon and X request ID, you need to add this part with new silicon and with the package X request ID, and both for the injector and extractor. Okay, after that, everything is done. So I put some sample code in my GitHub, and you can take a look and try by yourself. So this is our benefits. I using a sample to show our benefits. Maybe, let's say there is some problem with one API request. We want to get all the trace and the logs. We send this API with an UUID as the HTTP header with a header request ID UUID. With this UUID, we can query out the trace. Previously, it's not easy to query the trace, but now you put it here, put it text here, GUID X request ID with the previous UUID, put it here and click the button. Okay, that's cool. So the trace will be found out easily. And you can go to the details of the trace. You can find it will go to the Istio gateway. It will go to the full service Istio process and go to the full service application. So for different spans and includes a span of bar service Istio process and bar service application. Great. So you can find all spans connect together. So this is more useful. And we want to get all the logs together. So you can find since it go to the Istio gateway, we will find the logs and query and grep the UUID. You can find okay, the envoy access log is showed out. And then we want to find out the full service Istio process and grep it. Okay, cool. It is also showed up. And we want to see the full container. This is our application container. You can find for this log, for each log, the UUID, the ACK request ID is printed out as a prefix. Same for the bar service is a process, and for a bar service container. With that, as long as you put the UUID into the Kibana and query, all the applications, all the service logs related with this API will be queried out directly. So one thing you need to mention is the application need to extract the ACK request ID from the HTTP header, because ACK request ID is always forwarded by the Istio and our applications. So we get it and print it for each log as a prefix. Cool. Okay, so let's go to the final tip. So a quick debugging with the envoy filter. So here's a challenge. Some error rests on production environment for one application. However, this application logs is not enough. How to handle? The general way is developer add some logs and generate a new image and deploy this new image to the production environment and go to the release chain. It needs code change, right? It needs some time and even changes the code back. We have a better way. So we just add a simple envoy filter. We can get all the request and response header and body and print it out. And the developer can get this and take a look and maybe can use this to debug and reproduce in the non-production environment. This is the envoy filter. For this workload selector, you can limit which application should print such a body, or the body, also heads. We don't want to any application print such as so many heads and logs, right? And there are two functions. One is envoy on request and envoy on response. And for the envoy on request, you can print out all the request heads and body. Same for the envoy on the response, you can get all the heads for the response and print all the keys, values, and for the heads, and also print out all the body. I provide a code also. You can view it later, try by yourself. Okay, this is benefits. So this example is client said after we implement this, client said a request with this header like authorization, basic ABCDE, and with this form, this body token, and in the server side you can find out the envoy filter already print out all the heads, includes the authorization ABCDE, and includes the body. So it is pretty easy. And after you debug, you just delete this envoy filter. So it is very useful. Okay, I think that's all for our today's presentation. So Lisa introduced the access logs from envoy and the API monitoring and alert and I introduced the tracing integration and the quick debugging with envoy field. I'm very happy to have such chance to talk with you, and we provided a sample code, and you can take a look. And if you have any question, to feel free to ask Lisa and me. Thank you.